Our next contestant is Vineet Alexander, a PhD student in chemical and biochemical engineering. He is presenting to us on performance evaluation of a hydrotreater reactor.
Nowadays, the energy trend is towards renewable source of energy, such as wind, solar, etc. But at this present scenario, we are heavily dependent on non-renewables such as diesel and gasoline. A simple example, we all have automobiles here, and what it runs on? These fuels. To obtain these fuels, we have to drill inside the earth and get an oil out, and that oil is called crude oil. This crude oil is then subjected to series of processes to convert the crude oil to the usable forms such as diesel and gasoline. And this entire series of operation is called refining process. The first step of refining involves getting this crude oil out and treating it to remove the unwanted impurities out of it, and then subjecting it to other sets of reactors. This treatment process is called hydrotreatment, and the reactor we use it is hydrotreater. Hydrotreatment is a very vital process for the entire refining operation, because if it fails to perform, that means these unwanted impurities are carried over to the next stages of reactor. These unwanted impurities can cause severe damages to this reactor. Not only that, these unwanted impurities are heavy polluters too. So refiners have to make sure that they are working this reactor at its best. At industrial scale, this reactor is not performing at its best, but rather it is underperforming and incurring losses to the refiners. The main reason behind that is the flaw in the reactor design. By reactor design, we simply mean fixing the length, diameter, and other operating variables at which this reactor performs at its best. But reactor engineers designed it, but it failed. Why? Because they failed to incorporate certain key fundamental parameters in their reactor design model which directly affect the performance of this reactor. And why they failed is mainly due to the unavailability of technology to obtain and investigate these parameters. My research focuses on developing these technologies in the form of measurement techniques and numerical simulation, and implementing this in this reactor to obtain these hidden parameters. To do so, we scale down the industrial scale reactor to the laboratory scale, and we obtain these parameters and keep it out in the open literature. And by using this data, either we can come up with a new reactor design, or we can improve the existing reactor design itself. Improved reactor design means improve hydrotreater at its working. By improvement, it means it is using much less energy than the previous reactor, much more efficient than the previous reactor. And the most importantly, it is producing much cleaner fuel than the previous reactor, and that's what we need for our environment. Thank you.